Hello, in this video you're going to learn how to graph a quadratic equation from standard form. There are two examples here of what a standard form equation looks like. Something that I want you to notice is that these equations could have y equals, or they could have f of x equals. It does not matter which is at the beginning, they mean the exact same thing. In order for us to graph a quadratic equation from standard form, we're going to follow 4 steps. Step 1 is we're going to find the x-intercepts, which are sometimes called zeros. To find the x-intercepts, you follow the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Step 2 is that you're going to find the line of symmetry. We have a short little formula to help us find the line of symmetry. This formula is negative b all over 2a. Step 3 is you're going to find the vertex. And step 4 is you're going to double check should this equation have a maximum or a minimum. How you decide if something has a maximum or minimum is you look at the a value of an equation. If you remember, the a value is always at the beginning of the equation. So for instance, in this equation, our a value would be 5. If your a value is a positive number, your graph is going to have a minimum. If your a value is a negative number, your graph will have a maximum. So let's see these steps in action. We're going to graph y equals x squared plus 4x plus 3. Our first step is to find the x-intercepts, or the zeros. And again, to do this, we use the quadratic formula. So we need negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we were to complete these calculations, we would find that x equals negative 1 and x equals negative 3. So with these two values, I'm going to go to my graph, find my x-axis, and on that x-axis I'm going to put 2 dots. One at negative 1 and one at negative 3. Now for step 2, our line of symmetry, we have a new formula, negative b over 2a. So if I were to plug in those values, I have negative 4 over 2 times 1. And if I go through and simplify this fraction, I find that my line of symmetry should be negative 2. Now because our line of symmetry is imaginary, I'm going to use a dotted line to help me represent my line of symmetry. Now step 3 tells me I need to find my vertex. And to find my vertex, I'm going to take my line of symmetry value and plug it into my original problem. So everywhere that there is an x, I'm going to replace it with the number negative 2. So that would be negative 2 squared plus 4 times negative 2 plus 3. And if I were to calculate that, I would find that my vertex is negative 1. Which means on my line of symmetry, I need to go down one spot and put a point. Now with these 3 points, my only possible shape would be a graph that has a minimum. And if you recall, step 4 was double checking if my minimum and maximum make sense. Well, in this problem, my a value was a positive number. Anytime a is a positive number, my graph should be a minimum. So in this case, it double checks correctly. Let's try another problem. Y equals negative 2x squared plus 12x minus 16. Remember, step 1 is to do the quadratic formula to find our x-intercepts. So I need negative b plus or minus the square root of b squared minus 4ac all over 2a. And if I were to calculate this out, I would end up with my x-intercepts being positive 2 and positive 4. So again on my graph, I'm going to find my x-axis, and on my x-axis, I'm going to put a point at 2 and 4. Now, using my new line of symmetry formula, I'm going to find my line of symmetry. So I'm taking negative b over 2a, which is going to simplify to negative 12 over negative 4, which is simply 3. So again, since my line of symmetry is imaginary, I'm going to use a dotted line to represent it. And there's my line of symmetry. To find my vertex, I'm taking my line of symmetry and plugging it into my original equation. So everywhere there's an x, I'm putting my line of symmetry value instead. And I would end up with my vertex being at 2. So on my graph, I'm going to go up 2 spots and I'm going to put a point. And with these 3 points, my only option is to have a graph that has a maximum. Which again makes sense because my a value in this case was a negative number, so my graph should have a maximum value.